Okay, let's look at this solution here. Right. Question 3a, you are going to write a program that calculates the result of 1 plus 4 plus 7 plus dot 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 plus 34 until 34, and then send the result to port D after the additional process is done. Okay. So first thing first, what are you going to do? Okay, you need to identify the information from this question here. Right? So you are going to add this number here, 1 plus 4 plus 7 until 34, and then send out the result to port D. Okay, so in this question here, you need to initialize your port D as a output port or input port. Okay, you're going to make it as a output port. Okay, what about this calculation here? Okay, what are you going to do? Okay, you're going to do to find the difference, okay, from one number to another number. Okay, what are the difference here? Apa dia punya perbezaan dia? Plus 3. Okay, so each of the number here have different of plus 3. Okay, you need to increment 3 times lah. Alright, and then how many numbers that you're going to add here? Because you are going to do a loops 12. Okay, some of you maybe you add up all the numbers here, okay, and then find out what is the looping, how many loop that you're going to do. Or you can simply, okay, because this is your last numbers, correct? Why not we compare with 35? Okay, if this value here, x greater or equal than 35, we exit the loop. Okay, so we need to compare this number. All right, after you add all this number here, if x greater than 35, then you exit the loop. Okay, so first, what are you going to do? All right, so you know that this is a difference. Differences. All right, and then what about the first number, the initial number that you need to put? What is the, okay, this is the first number. Right, and then port D, you need to make it as a output port, and then you exit the loop when your, what we call here, your x greater than 35. Okay, so first what you're going to do is you need to include m32def.inc. Okay, always include this file here. Okay, selalu tambah file ni ke dalam kamu punya program. Okay, next, barulah kita, next we are going to initialize our port D as a output port. How to initialize port D as a output port in assembly language? Macam mana nak buat? Okay, so initialize DDRD as an output. Okay, so make sure that DDRD, you need to give 0 or 1 to make it as an output. You need to put 1. Okay, give 1 to your DDRD, and then what happen is your port D become output port. Okay, so load I R16 0xfs out DDRD R16. Okay, so this one here, port D sama dengan output. Okay, you make it as a output. Right, next, what are you going to do? Okay, so this is your first number. Okay, so you need to load lah this number here to your register. Okay, we use the load I R19 with 1. Okay, makes your R19 sama dengan 1. Okay, next, what are you going to do? Okay, you're going to add R19 with another register. Okay, for example, this is R20 lah. Okay, So what you're going to do is you need to clear first your R20 because we're afraid that R20 has a number inside here. Okay, so we need to clear the R20. Okay, let's clear the R20. CLR R20. So R20 equal to 0. And then what are you going to do? Lepas tu, okay, you add lah. ADD R20 with R19. Okay, so first kosong 0 you plus with 1. So R20 now we have the first number 1. Okay, next what you are going to do? You increment your R19. Okay, increment R19 how many times? 3 times because the difference here from first number to the second number is 3. Okay, you need to increment R19 3 times. Increment R19. Okay, so now your R19 now will get new number which is new value which is 4. Okay, then you add R20 with R19. Okay, so you become 1 plus 4 and it keep repeating. Okay, after that, what are you going to do? After we increment the R90, you compare lah. Okay, compare your number. Okay, your R19 with 35. Okay, so using a CPI. CPI R19 with 35. Okay, you compare your number, which is your X here. X is your R19 with the 35. Is it greater than 35? If no, you loop. Okay, keep doing. Okay, keep adding and incrementing your R19. Okay, so we use the BRLO. Okay, if BRLO, okay, so you put lah ulang. Okay, where I want to put my ulang here? Okay, put at ADD. Oh, Daniel, it's just you that don't have no audio. Okay, others can hear my audio. Sorry. Okay, wait ah. Okay, next after we put the ulang at ADD, lepas tu nak buat apa pula? Okay, it will keep repeating until lah. Okay, your X greater than 35. When your R90 is greater than 35, what happen is you need to send out. Alright, you need to send out the result to your port D. Okay, how to do that? By using out port D R20. So what happen here? Port D equal to result. Okay, all of you get this answer here. Semua dapat ya? Okay, next we move to question 3B. Okay, so here 3B. Okay, given the content of register as in the table below, okay, and this table here, you are going to complete the final result in the destination register. So the answer should be in a hexadecimal number after executing all of the following instruction. Right, and these instructions are executed sequentially. Okay, So, okay, so the first line here, ADD R20 R21. Okay, what the first line do? Okay, you're going to add R20 with R21. Okay, 19 plus with A2, you get, what is the result here? You get, okay, kamu akan dapat 132. Okay, since this one here, okay, 132 is more than 8 byte. Okay, R20 only 8, sorry, not 8 byte, 8 bit. Okay, R20 only 8 bit. So, you need to divide this answer here to low and high byte. Okay, so low, which is 32, will go to your R20. You will put the result to R20, while 1 here will go to your carry flags. Okay, next. ADC R22 with R23. So R22 kamu ada F3 plus with 05 and plus with C. Okay, don't forget to include C, your carry. What is your carry? Your carry now is 1. Okay, you need to include this carry here. Okay, so what is the result here? You get, kamu akan dapat F9. Okay, so you just put F9 here. What about carry flag? What is the value of carry flag after you execute ADC? Okay, no longer 1, because after you add this number here, R22 and R23, there is no carry flag from bit 7. Okay, so your C become 0. Okay, this is F3, 1, 1, 1. 1 tambah dengan 0, 1, 0, 1, 1. This is F3. Plus with 0, 5. 0, 0, 0, 0. 0, 1, 0, 1. This is 0, 5. And plus with carry. Okay. So you add this number here. 1 plus 1 plus 1, you get 1. Okay. You have carry. 1 plus 1, 0. Okay. 1 plus 0 plus 1, you get 0. And 1 plus 0 plus 0, you get 1. Okay. 1 plus 0, 1, 1, 1, 1. And there is no carry here. So that's why the carry flag become 0. Okay. So F9. Okay, this is F9 with carry 0. Okay, semua dapat ya? Okay, next. SBC R21 R23. Okay, so R21, what is R21? A2 minus with R23. Okay, 0, 5 minus with carry. Okay, don't forget to include the carry. Okay, since the carry here, the current carry is 0, so you minus with 0 lah. And you get A2 minus 0, 5. Kamu akan dapat berapa sini? 9D. Okay, you get 9D, so you just put 9D here. What about your carry flag? Carry flag 0. Okay, because you not borrow from bit 7. Okay, so that's why the carry flag is 0. If you borrow from bit 7, or sorry, from outside to bit 7, and then you need to put carry flag equal to 1. Okay, next. EOR. Okay, what is the EOR? EOR stand for exclusive OR. Okay, so you need to know the truth table of your exclusive OR lah. Okay, 0, 1, 1, 0. Okay, so EOR R23. What is the R23? Masih lagi 05. Okay, which is 0, 0, 0, 0, 0, 1, 0, 1. Okay, you just put 8421, 8421 to easy to change from hexa to binary number. Right? And then what about R21? What is the R21? Okay, the R21 no longer A2 lah. It become 9D. Okay, this is the current value of your R21. Why? Because you executed that instruction sequentially. Okay, so 9D, what is a 9D? 1001. What is D? 13. Okay, 1101. R20. Oh, sorry, R20. R20 is 90 bukan R21. Okay. So R20, not R21. Okay, thank you. Okay, so R20, what is the current value of R20? 32 Okay, 0011 and this is 0010. Okay, and after that you compare lah with this truth table here. Do the exclusive OR. 10 become 1, 110, and this one here become 1100. So you get 3 7. Okay, so just put 3 7. Okay, next, negate R20. Okay, what is the negate do? Okay, if you're not sure what the negate do, you can refer to your instruction set summary. Okay, so you find out what is the negate, right? So this is the negate here. Mana dia? Okay, this is your negate. Okay, which is you going to do a 2 complements. Okay, if you don't know how to do a 2 complements, okay, you can refer to this operation here, which is 0 0 minus with RD. Okay, so you take the value from RD, you minus with your 0 0. Okay, so in this case here, what is the R20 value? Okay, R20 masih lagi 32. Right, so 00110010. Okay, then you do a second complement. How to do a second complement? Okay, from right to left, okay, find the first number 1. Okay, so this is your first number 1. Okay, then you copy back the value, while the rest you just invert the value. Okay, so kamu akan dapat, what is this? 84 is 12, 12 is C, okay, and this one is E. Okay, so you get C, E. Okay, next, the next line is MOVW R20 R22. Okay, what this thing do? Okay, you want to move words, okay, from R22 and R23. Okay, this is the pair R22 is with R23 lah, while R20 the pair register is R21. Okay, you want to move value from R22 R23, okay, put to R20 R21. Okay, what is the current value of R22 R23? This one lah, F9 37. This is the current value of R22 and R23. And now you want to copy this value here to R20 and R29, R21. So it become F9 3 7. Okay. Okay, you can refer this instruction set summary. Okay, where is move? Mana kat mana saya punya move? Move MOVW. MOVW, where is MOVW? MOVW. Okay, this is MOVW, in which you want to copy a register pair. Okay, you see there RD plus 1 RD. Okay, RR plus 1 RR. copy this value here, put to your RD plus 1, RD. Okay, next. SBR. Okay, what the SBR do? SBR R22 170. Okay, so this 170 here, is it hexadecimal number or binary number or decimal number? 170. Okay, it is a decimal number, yeah, because you don't have any symbol in front of this number, so it is a decimal number. Okay, so you need to convert this number here to binary or hexadecimal. 170. Okay, you convert to hexa and after that you convert to binary. Because why? Because we are going to do the SBR. Okay, you can use either hexadecimal or binary number. Okay, if you're going to use a hexadecimal, okay, first thing first, we are going to see what the SBR do. Apa yang SBR buat? Okay, let's see what is the SBR do. SBR. Okay, this is SBR. Okay, set bit in register in which the operation here RD X. Okay, you OR with K. Okay, the value from this K here, put the result back to your RD. Okay, macam mana nak buat ni? Mana yang lagi senang? Hexadecimal or binary number? Okay, you're going to use the binary number. Okay, what is your RD? RD is R22. What is our current R22 is F9. So this is F9 1111 1001. Okay, 170. 170 you change to hexa, kamu akan dapat AA. Okay, from AA you change to binary, you get 10 10 1010. Right, next after that you do the logical OR lah. Okay, you do the logical OR. What happen is dia akan jadi 1101 1101. Okay, and then you change back. Okay, betul lah? No, 111. Okay, so this is the value here. You get F B. Okay, kamu akan dapat F B. Okay, next. CBR R2385. Okay, what does CBR do? Okay, refer back. CBR, okay, says that you are going to clear bit in a register. So this is the CBR in which RD, okay, you end with FF minus with K. Okay, mula-mula kamu kena tolak FF minus with K, and then you do a logical AND with the value from RD. Okay, so what is the current value of your RD? RD R23 is 37 0 0 1 1 0 1 1 1. Okay, so this is 37. Okay, and then now you have 85. Okay, 85 convert to hexa, you get 55. Okay, but bear in mind that you're going to minus with FF. So FF minus with 55, what you get? Dapat berapa kat sini? Okay, you get AA. Okay, so this AA here, okay, you put down here 10 10 10 10, and then what operation that you're going to do here? Okay, you have the RD 37 and then AA, okay, the value here, and then what you're going to do? You're going to do a logical AND. Okay, make sure that you know lah the truth table of logical AND. Alright, so 10, what value you get here? 0 1 1 1 1 0 0 0. This is also 0 1 0 and 0. So you get, kamu akan dapat 2 Okay. So next, I give you around another 15 minutes, okay, to do a question 4A and 4B. Okay, boleh ya? And then after that, we discuss the answer. Okay, you are given a variable A, B, C, M, and N are 8-bit signed number. Okay, dia bagi tahu kat situ, this variable A, B, C, M, and N are 8-bit signed number. Okay, so this is signed numbers. Store in a register R0, R1, R2, R3, and R4 respectively. Okay, means that R0 is your A, R1, B, C is R2, this one is R3, and D is N is your R4. Okay, all of this register here is a signed number, 8-bit signed number. Okay, you are going to write AVR at Mega32 codes that will execute according to the flowchart shown in the figure below. Okay, so this is the flowchart, right? So what are you going to do? Okay, the first here, it says that M equal to A, N equal to A. Okay, you need to copy lah. Okay, your M, so that it become A, as well as your N equal to A. So macam mana nak buat? How to do that? Okay, for this line here, okay, we're going to use the what instruction to copy a number between to copy a value between registers, because M and N is R3 and R4 while A is R0. Okay, you need to make this R3 sama dengan R4 sama dengan R0. How to do that? Okay, we are going to use the MOV. Okay, so MOV R3 with R0 and MOV R4 with R0. Okay, so the first chart here is complete. Okay, next. Is it M equal to B? Okay, what are we going to do here? Okay, you're going to compare lah. Is it R3 smaller than B? What is B? R1? Kalau betul, if yes, M equal to B. Okay, you copy back. R3 equal to R1. If no, then you need to compare with N. Okay, so this one here, you're using a CP. Compare. Compare R3 with R1. Okay, is it R3 equal to R1? Right? If R3 is greater, which is no lah. Okay, we are going to use BRGE and BRLT. Why? Why are you using the BRGE and BRLT, not BRLO and BRPH? Kenapa? Okay, because the compare here. Okay, you see here. Okay, for the compare branch here. Okay, you have a BRSH. Okay, this one here. And then satu lagi BRGE, BRLT. Why not using the BRSH and BRLO, but we need to use a BRGE and BRLT? Kenapa? Why? Because it is a signed number. Okay, you see a signed number. BRGE and BRLT are for signed number, while BRSH and BRLO for unsigned number. So that's why we choose BRGE and BRLT. Okay, so here BRGE. Okay, what happens when it's greater? Okay, you go to here lah. So this one we label it as a L1 lah. Okay, go to L1. If not, What happened when not? Okay, so move R3 with R1. Okay, kalau M greater than B, so it will go to here, L1. Okay, you need to compare N with B. If not, M equal to B. Okay, semua follow All of you can follow Alright, next. What we're going to do? Dekat L1, this is your L1. Okay, you need to compare again. CP. Okay, so you put lah L1 kat sini. Okay, because you want to move from here to here. So this become your L1. Compare N. What is your N? R4 with R1. Okay, you're going to compare R4. Is it R4 greater or equal than R1? Okay, so if BRGE is here and BRLT okay, so if yes, N equal to B. If no, okay, you lompat ke L2. Okay, compare another numbers. Okay, so here what you're going to use is we're going to use a BRLT or BRGE. Kita akan guna BRLT. Okay, we are going to use the BRLT. Go to level 2. Okay, so if we go to this level 2, so this is your level 2. Go to here. If not, what happen? Okay, because your N is greater and equal than B, what happen is you need to move R4 with R1. Okay, next. Lepas tu buat apa pula? Okay, at level 2. Okay, you need to compare again. M, what is your M? R3. Is your R3 is smaller than C? What is RC? R2. Okay, is it BRLT? If yes, M equal to C. If no, this is BRGE lah. Because M greater than C. So you need to go to level 3. Okay, do another comparison. Right, so this one here, CP R3 with R2, where if the R3 is greater than R2, go to level 3. If not, what happen is, okay, if not, this one here, R3 sama dengan R2. Okay, so R M O V R3 R2. So this is level 3. Okay, so at level 3, what are you going to do? Okay, you need to compare again lah. Okay, so compare again. So now this is R4. Is R4 greater or equal than R2? Okay, if yes, which is you using a BRGE lah. If not, BRLT. Okay, so if not, what happen is you exit lah. Okay, do the jump here, here. Okay, which is this is a level 4 lah, the last level. Okay, so compare again CP R4 with R2. Okay, you compare R4 with R2. Next, we are using the BRLT. What happens when N smaller than C? Okay, you go to level 4. If N greater than C, what happens is you move R4 with R2. Okay, so this is your level 4. Okay, jump level 4. Okay, so it will keep repeating here. Okay, any question? Ada soalan tak untuk question 4A1? Okay, you need to interpret this flowchart here and then do the program according to this flowchart. Right, next, describe what the flowchart of figure Q4 does. Apa yang flowchart ni buat? Can you tell me what this flowchart do? Okay, you have three numbers A, B, C. Okay, in which first you set this A here with M and N. Okay, then you compare this number here with B and compare again with C. So what this flowchart do? Can you tell me? Apa yang dia buat? Come on, hurry up. Anyone? Okay, before we stop today. Okay, and then for B and the rest of the question we'll do next week. We'll discuss next week. Okay. What happened here? Okay, you have three what we call three numbers here, which is A denoted as A, B, and C. And then after that, you make your A here with M and N, and then you compare with B. First you compare with B, and then you compare this number here with C. Tak ada? Okay, so this one, what you're going to do is you want to find, okay, maximum and minimum of A, B, and C, in which M is your maximum number, while N is your minimum number. Okay, you're going to find what is the minimum and maximum number from these three numbers here, three variables here, which is A, B, and C. Okay, you do a comparison, and then at the end, the one with M, it is a maximum number, and the one with N, it is a minimum number. Okay, do we need to discuss this question here, or we'll just call it a day? Okay, this one we'll discuss next week. Boleh tak? Okay, boleh. Okay, I think we stop here.